Hello everyone, welcome to another video for Algebra 2. Mr. Beceda here. Our video today will be on solving equations with inverse operations, a topic that seems pretty familiar, and it should be. We'll just be adding a few things. So we're going to start by taking a look at this first equation here, x plus 8 equals 10. Now most people would see this equation at the level you all are at and say, probably the first step would be to subtract 8 from both sides. And that would be correct. And we get x equals 2. And that's all well and good. But the question we want to ask ourselves is, why were we subtracting 8 in the first place? And the answer to that is inverse operations. The reason that we subtract 8 to solve for x is because the equation had a plus 8, and we solved because subtracting 8 is the opposite of adding 8. We, of course, have to do that to both sides to keep things balanced, but the whole idea there is inverse operations. Inverse meaning the opposite. So to start today, we're going to take a look at a few operations and talk about what their inverses are. Now, the first operation we'll mention is one that we just did, which is addition. The inverse of addition would, of course, be subtraction. And we saw that in the first example that we did. If we had an x plus 8 equals 10, we would subtract 8 from both sides because subtracting 8 is the opposite of adding 8. And we're left with x equals 2. Now this goes in the reverse direction as well. If subtraction is the inverse of addition, then addition is the inverse of subtraction. These things are reversible. So if we look at multiplication, of course the inverse of multiplication would be division. And what that means is if I see multiplication in an equation, for example, 5x equals negative 20, x is being multiplied by 5, and the opposite of multiplying by 5 is dividing by 5. That allows me to cancel out the 5, leaving me with x equals negative 4. Now those you've seen a lot. We'll take a look at two more operations that we don't see as often. And the first one is squaring. So the opposite of squaring something would be taking a square root. Now what does that look like? Well, say for example an equation had x squared equals 25. To get x by itself, we need to undo the squaring. And the way we undo that squaring is by taking a square root. Of course, we will do that on both sides of the equation, leaving us just with x on the left and the square root of 25 on the right, which is 5. Note that on the left-hand side, the square root canceled out that x squared. And raising it one more level, the inverse of cubing something would be to take a cube root. Now, most people have heard of square roots before, not as many have heard of cube roots. Well, let's say we had x cubed equals 8. The inverse of that, the inverse of cubing would be taking a cube root. That looks exactly like a square root, but we put a small 3 there. And when we're taking a cube root, the question is, what number times itself 3 times gives me 8? And that gives me x equals 2. We'll talk more about square roots and cube roots in class, but I just wanted to give you a quick start on that. For the remainder of this video, we'll just take a look at a few equations and work on using inverse operations to solve them. So in our first one here, 4x equals 60. 4x means 4 times x. The opposite of multiplying by 4 is dividing by 4. We will divide both sides by 4. That leaves us with x equals 50. In our second one, we've got two operations on the left there. X has been multiplied by 4, but we also have a plus 2 on the end. The inverse of adding 2 would be subtracting 2. And as we saw at number 1, the inverse of multiplying by 4 would be dividing by 4. We've seen these equations before, but now we're seeing it a little bit in terms of a context of inverses. Now, if I look at number 3, question number 3 looks very similar, except I now have parentheses. And one of the best ways to deal with parentheses is to distribute them, so I'll do that first. Note that when we distributed that 4 into the 2, that became an 8. I will then apply the same inverse steps I did before. The inverse of adding 8 is subtracting 8. And again, the inverse of multiplying by 4 is dividing by 4. That will come out to be a decimal. That's not a problem. Our answer here is negative 7.5. Now on the next one, oftentimes people worry about fractions. In number 4, we have y divided by 6 equals negative 7. But if we think of this fraction as division, which it is, we can just ask ourselves, well, what is the opposite of dividing? The opposite of dividing is multiplying. So we'll simply multiply both sides by 6. That will cancel the division on the left. And negative 7 times 6 is negative 42. And that's it. So don't be afraid of a fraction bar, because the fraction bar simply means division. We'll look at 2 more and then wrap things up here. With number 5, we have m divided by 8 minus 10 equals negative 2. Now, in terms of what operation should happen first, I always try to think, what's farthest away from the variable? The dividing 8 is directly underneath the m, so I'll have to deal with that at the end. So the first thing we'll do in number 5 is counteract the minus 10 using the inverse, which is addition. We will add 10 to both sides first. And then, to counteract that dividing by 8, we will multiply by 8. Giving us a final answer of m equals 64. In our final problem here, number 6, we have something a little bit different. We have a few terms on the left-hand side of this equation that are combinable. Always look for that first before we start doing inverse operations. I've got a 2x minus a 4x. That combines to give me negative 2x. Negative 2x plus 8 equals 2. And now I can use those inverse operations. I'll start by counteracting the 8, which is a plus 8. The opposite of adding 8 is subtracting 8. And in our final step here, x is being multiplied by negative 2. The opposite of multiplying is dividing. And that leaves us the final answer of x equals 3. Hopefully this video helped you to see a bit of how inverse operations works. In this video, we've primarily focused on adding, subtracting, multiplying, and dividing to solve these equations. However, in class, we will take a look at solving with square roots and cube roots to help complete your understanding of inverse operations. Thanks for watching, and we'll see you in class.